Okay. It is 8:13 p.m. Why are we live at 8:13 p.m.? Frankly, I have no idea. But I guess we are, and we may as well do some work. Just a little bit. I just really want to figure out this one thing with the returns on this. It drives me nuts. And I don't understand what the hell is wrong. Hey, Bet. Good point. I'll do that. Slightly better. Ah, that's too bright. Hey. This reward thing is weird. This reward thing is very weird. $60. So I'm trying to think how this would work. You're fitting this to the variance of the return. Oh yeah. You get a value function out of this. The predictions are pretty darn variable. I wonder why. It's 0. And then block 0. A mess. But the value function is normally trying to predict this, isn't it? With squared error. It is. Does this get better if we run it for longer? New algo stuff, I assume, yeah. Extricated the advantage. Well, it's different. It's, in this case, the discounting itself is learned. Or it's supposed to be. So you have hang on, how does this make any sense? Reward block. This doesn't now, does it? I think this is still wrong. How is it still wrong, though? Hang on, maybe this just doesn't get zeroed. Oh, 09, huh? Yeah, something's very weird there. R plus bootstrap. No rewards. Oh, 0059. Weird. Now this, on the other hand, does have a bunch of data in it. There's no learnable gamma on this either. Not at the moment. Oh wait, no, there is. It doesn't go backwards though. So, does that make sense? The math is just tricky here. So you predict, you get a value for each, predict for each mean and standard deviation. We aren't learning value function at all. We are learning value function, where in fact we're learning a very large and variational value function. You predict mean value for the next horizon steps, as well as standard deviation. But the question is what to fit those two. So if the value is supposed to represent the discounted return, how does this work in the normal PPO setting? You end up with discounted rewards, the value function bootstrap at the end, right? Yeah, you do. And the value function is trained to maximize discounted reward. Is that different from what I've just done? Let me see. There might be an error there. Advantage. Where's the value function trained? Target, advantage plus value of ST, discounted reward. Okay. Was it? Yes. Maybe there's no contradiction here. This is correct. Huh? T, yeah. Oh, hang on. No, this is fine. I'm just trying to figure out if there's something circular here where you destabilize it, because the thing is you're using the value function to compute the advantage, and you're using the terms of the advantage to train the value function. So it seems a bit circular, but maybe it's not. And I'm looking at my case here, and I'm thinking that maybe my case isn't really circular either. But I need to think a little bit about the discount factor still. So gamma's in the original it is, not in mine. These. By the way, I highly recommend these. These are, where is it? I don't know if you can see on camera, 0.5% alcohol. And it just tastes like a good normal beer. So I get to have beer again without having to have the alcohol. It just send me unlimited of this stuff. Not really. They've got 65 calories apiece. I am getting kind of fat, but that's just gonna happen until I get back to my original weight and am able to start cutting. Oh. What line are you learning gamma here? Um, well, technically that would be here. It's a Gaussian negative log likelihood on the mean value, computed return, and then the variance predicted for that value. I mean, I've been deving this on stream for a while here. But I'm trying to figure out here. If I do the prediction this way, do you need the exponent for some reason? Maybe you do need the exponent, right? It's so hard to think about this because it's like it's a telescoping sum, and then you have to understand the interpretation of that sum and how it behaves if you optimize it. Nah, fuck that. I'm gonna do the problem when I want to do the problem. Very useful. I mean, I know how I would apply the discounting factor if I wanted to have a telescope. Actually, I think it does have to. Yeah, I think it does have to, right? Because the thing is, if I'm trying to make this be like, it's hard to say, honestly. I could just do it that way. Actually, hang on, let me think about this. Maybe there is a principled way of approaching this. Hold on. That contribute as much ahead of time. Oh wait, so that's very weird actually. So if you predict, I really don't know if you have to apply this exponential or not. I think it should just learn it. I would think. Maybe I'm wrong. It's very difficult to develop an intuition around this thing, and it's even more difficult to explain it on the stream. Does this thing train as it is now? Not really. Am I sure that this is correct, though? Return branch? What do you mean? Oh, yeah. Standard deviation is much lower. You go farther out. It's a problem. It goes up at a reasonable rate, at least. Not really. No, it doesn't. I have versions that do. I mean, I guess the closest version of this would be try this. They're just some intermediate things I was looking at. Is it still gonna explode? Shouldn't. It still explodes a little bit. Oh yeah. We're having the buffer. Let's see. What gammas we're coming up with. very odd. Yeah, okay, so that shouldn't happen, right? And it goes to 0. You need to run the test. No, can't be right. Trying to think what a good way to test this would be. R minus values mean. Drive me nuts, isn't it? I need to write a really good test. Yeah, it's not good. I mean, there's just too much in here that's not good. Maybe I just have to go over it very carefully. It's the last value predicting. Oh. Yeah, I think it's the wrong thing here. I think it is the wrong thing. I think if I'm going to do bootstrapping, I think it has to be done completely differently from this, doesn't it? Yeah. Do like this. Now, if I think about this without bootstrapping, then I don't think that you need this this gamma, right? Might be easier to learn. I don't think you need it though. Hang on, maybe you do. It's supposed to be the uncertainty. Uncertainty will increase over the horizon, which will cause the behavior that we were seeing. Okay. Let me think about how that should be handled. I see. Yeah, that is a problem. really starting to wonder if I shouldn't have done this in CUDA, but I think I have to. The uncertainty should come from or the discount should come from the uncertainty of the value function, shouldn't it? It should. It definitely should. It might need to be scaled though. Bro, what's the problem? Yeah, I'm not explaining anything very well at all. So this is a new advantage function aiming to replace generalized advantage estimation. It works by, instead of predicting a single value trained to match discounted returns, it predicts values for the next 32, 64, or say 128 steps, 128 different values. It also predicts standard deviations for those values. So it's variational. And the goal is to use the standard deviations, which give you the uncertainty of those predictions, in order to learn a discounting factor. So in essence, this thing is supposed to be able to learn to do credit assignment over different horizons based on its certainty um, in what rewards it thinks it's going to get. But it's kind of a little bit of a mind bender here with how you set up the value function training. And that's what I'm trying to deal with at the moment. The code that I have here is a CUDA kernel for this advantage function, because it's a little annoying the way it works, and it's horribly, horribly slow if you don't write a kernel for it. Very fast if you do. Whatever, it's just breakout, but that's irrelevant. This is not like a this env or that env problem. It's like a very core fundamental algorithm problem. I'm gonna get this though. It'd be very, very good if I could get this to work. Yeah, the thing is, like, I've already kind of seen that on Breakout, you can get something to perform very well, with like even completely unreasonable things. So it's really about getting the design of it correct and then testing it in a lot of M's. Sounds complicated. Good luck. Not my sphere. Yeah. Well, I mean, this is, sometimes this stream is watch me build cool environments live. Sometimes the stream is we just deal with really hard research problems that are not exactly in my area either, because that's what is needed to push reinforcement learning forward, right? And like, if you ask a very good math guy, the stuff I'm going through is going to look very stupid, but who cares? We're going to solve it eventually, and we're going to have a nice algorithm. So that's the core issue. Maybe I will start like diagramming some of this stuff out. It'll be more interactive, and maybe I'll solve more stuff that way. Okay. Oh, that is blinding. Okay. So the neural net is going to output BT plus 1 T plus horizon. And then it's also going to output sigma t, sigma, oops, not how you write sigma, t plus 1. Okay, so these are what we have. Now we need to define two functions, just two functions. We need to define advantage sub t. We'll give it a hat because it's an estimate, I believe. Okay. And then this is going to take in as parameters. You're allowed to use v, t, and we'll give this a vector. You're allowed to use sigma, t, vector, and you also get the rewards, t. Okay, so we need this function, the advantage function, and then we also need we also need the value function. But the value function is very similar to this. All we really need for the value function is the return. And if we just do return equals, well, it's in the PPO paper. Let me find it. It's a simple formula for that. Yeah, so advantage is just, return is just this plus v. Okay. Advantage plus v. Let me write that in. Return t equals a hat t plus v t, and there's no vector on this one. So that one is easy. So really, we just need this advantage function. Okay. And I think what we're doing right now is we're doing gamma gamma sub I equals, so it is 1 over sigma squared I over max I sigma squared. So this is just a norm. So it's just normalized 1 over sigma squared. Okay, and then we're doing sub t equals minus v sub t plus, I guess we don't really use this v sub t here at all. This is about what we've got. So one thing you notice is that this sum strictly increases the farther out you go. You know, I'm wondering if we do keep the exponential on here. I don't even know if that fixes it. Well, hang on. Because we also need to get so this is the advantage right here. This portion. What do we do about the importance weighting of these terms? Why isn't this a problem normally? A problem normally because you have fixed gammas, right? And they're applied exponentially. And they're not trained. Okay, so the problem here is that this is trained. Oh, okay, I think I see the solution to this. I think if this is just square root. Variance scales linearly. Variance of the sum is sum of variance. Okay. So you divide by n. Maybe we try this next. You divide by max of gammas as well. I guess you would. But that's going to mess it up, isn't it? No, that's going to mess it up. And then you divide by the max. Did you do anything special? You might not have CUDA dev tools, or the dev version of CUDA, I mean. Okay, we're getting some numbers here. Now, are these the numbers we want? Okay, you know what? I have some ideas. Again. Reward block gives you gamma, right? Okay, so equals the reward. gamma times r. Yeah. Hang on. No, this doesn't make sense either, does it? Not quite. Yeah, it still doesn't quite make sense, does it? Maybe it does. Wait, let me think. If reward block contains the sum of rewards, the value is trained to predict that. Hang on, I might have something still. This brings us back to mean reward, doesn't it? Have it training? Yeah. It's hard. I could predict I don't think this helped me. This gives me a clean reward signal to train on. Is that useful though? What's the advantage function then? Yeah, I don't know what advantage you'd do then. You're already predicting. Yeah, it seems weird to produce a value estimate like this at every step, doesn't it? It seems very weird to produce a value estimate like this at every step. Hang on though. Maybe I do have this. I had this correct earlier. So if I just do, if I predict per time step, right? It's hard to learn that. It's not really that much harder to learn though than the other one. Okay. So let me say I produce per time step value estimates. And then the advantage is going to be the sum as before. Maybe that does work. It's easier to implement. Maybe that was it. Maybe I had it right the whole time. I just second guessed. What time is it? 9:26. Okay, we're gonna do this for a little bit and then I'm gonna sleep. Make a commit though. we need to divide by n. You divide this by max gamma. And then what do you train this against? Buff. Reward block. Maybe that's just it. With my printing. Just reward block. Hang on. I have something I think is right now. Might need tweaks, but I think the concept is now right. Perfect. So last value is suspicious. It's fine though. So y the top value should be 1. Oh, it means the last gamma is too high. Yeah. Okay, so why does that happen? Why does it happen? Right? So this is an indexing bug, I assume. Right here. Ah, hold on. It's because you have to go forward a step, isn't it? Yes, because you have to go forward a step. So the last gamma predicts. What's the last gamma predict? Can't predict anything, right? So then the alternative, I guess. -1. Okay. I'm a lot happier with that. Okay, that trans something. Think about the scaling of this. I mean, this is not an unreasonable horizon. But the issue is going to be this will plateau flat. It's the issue. Oh, hang on. Maybe there is something I can do. Horizon is 32. By default, it is. Yeah, this is kind of weird, though. Maybe it should be sum or minus value mean over that. That would be thinking, right? Maybe that's it. But wait, how do you do... Then I have to scale it so that gamma... Oh no, this works, right? And then this would work, wouldn't it? We'll see. Make another commit. Okay. I have an idea here. Oh. Yeah, this is totally wrong anyways. Well, what's wrong with you? Semicolon? Right. Does this make sense? You're now training against the true return. What does this get you over? Well, it tells you how to weight each one of these, doesn't it? Yeah, I like this. It's not bad, 650 on a trial run. It's passable. Well, lots of things work. The question is whether it's better. Well, we're gonna run it on breakout. I would really like to not have to zero these buffers. Let me just make sure it still trains if I do that. I think you do have to zero the mask block. Make sure it's consistent. Yeah, but we're gonna see if it does it faster. Or about as fast at least. I'd settle for at the same speed. If it does it at the same, so if this algorithm works at the same speed for a variety of m's, it's a win. Because it kills two hyperparameters. Come on, it's different. Yeah, it's different. Okay, well, let's make sure this one works. Again. Make sure this repros, and then we'll run it as a sweep. That's good progress, at least. Do we have people yelling at me? That's funny. Cope. Yeah. I swear, if you just post anything negative about AI at all, and like not even like pessimistic about tech, but just like, hey guys, you should probably still learn to code instead of just like, brain damage replacing your intelligence with Grok or GPT. It's like, no, I don't want to think anymore. I want the AI to think for me. It's like actually ridiculous. I mean, it's kind of just crazy to me, right? Like, imagine being a lazy fuck who just sits on your ass all day, who doesn't bother to learn anything, and then gets mad at the on the internet when people say, "Hey, You should probably learn something instead of hoping that AI will just outsource all forms of intelligence. Like, especially the programming hate people. It's like, okay, imagine that people have dedicated years or decades of their life to getting good at actually understanding how these systems work and building the AI, and now you're like, ha, loser. Imagine being a programmer. Imagine building this AI when I can just use the AI that you built. It's crazy. I don't get it. I don't get it, but whatever. Enough stupid rambling. Use similar. And if you're bad, you really can't 10x is the thing with AI the way it is now. It's too stupid. Ironically, you can only 10x what you're producing now if you're bad, right? If you're really, really bad, it'll give you something like kind of passably acceptable, but not really. Does it actually? That's hilarious. And actually, the reason that I went down that whole rabbit hole with the other version of that function in the first place is from a stupid Grok suggestion. Which, I mean, it took me a really long time to figure out why the suggestion was stupid, to be fair, but it was stupid in the end. And mind you, that's not in an area where I'm exactly, up on my game of what is. Like, I don't spend all day doing math most of the time. I really don't. Oh, shoot. This one is. Right, so we're going to get this launched. I think it's also I think it's fair that we comment out gamma and lambda, right? We don't need to sweep them if we're not using them. So that is part of the advantage. No, it's not edgy. It's just one less variable going into the Gaussian process, or two fewer variables. I'm not committing this. I'm just doing it for the experiment. There actually really only are, oops. So there really only are 4 really key hyperparameters, right? It's in a rough order. It's learning rate, gamma, lambda, and entropy. Okay, so that runs. Let's just you'll get the training stuff soon. Cool. And then we'll try some stuff after. I mean, this is a good progress. Yeah, there, 1.1, 1.2 million train. Very nice. We'll see how that goes. You know, no big expectations for it, but it's cool. I found this old GIF. This one's fun, right? Big neural MMO map. We should do more with this end. Okay. I think that'll be it. I think I'm gonna go get some rest. Send an email or two maybe, but I need to mainly just get some rest. Twitter's been going well. I gotta post more Pokemon stuff. It's hilarious. All right. I'm gonna get some rest. So, a couple of folks watching. All my stuff's at puffer.ai. It's all open source. You want to help us out for free? Start the GitHub, join the Discord, and follow on X for more content. The blog here, including a nice RL quick start guide for beginners, and there's stuff for cutting edge as well. So thank you, and I will probably be back